Hello, welcome to the Personal Tutor Virtual Classroom. This is physics for senior high school. I must say, the enthusiasm with which you are studying the lesson is highly commendable, and Personal Tutor promises to be a very good friend as long as you embark on this academic journey. We are looking at kinematics, and in our previous lesson, that was lesson number 5, we did discuss the various graphs of motion, where we talked about distance time graph, displacement time graph, and the velocity time graph. We looked at the various detailed definitions and explanation to those graphs. Today, our attention will still be on the velocity time motion graph, and this is lesson number 6. The learning outcome is that at the end of today's lesson, you should be able to sketch the traveling graphs for the velocity time motion graph. That is our task for the day. But before we continue, let's take a recap of the various graphs under the velocity time motion graph. We said that a graph of this nature was called no acceleration or uniform velocity. So take notice of that. When a question says a body moves on a constant velocity or maintains this velocity, it is in reference to this kind of graph. Another one was the uniform acceleration. That is, the acceleration is maintained throughout the journey like this. And the last one is a deceleration, where a body is brought to rest finally. So take notice of these 3 graphs. We are going to just put them together to form various shapes. And that will be the only thing to do for today's lesson. So as already introduced, we are learning how to sketch the traveling graphs for the velocity time motion graph. Let's start with example number 1, which reads: a car initially at rest accelerates uniformly to a velocity of 20 meters per second for 10 seconds. It maintains this velocity for 5 seconds before decelerating to rest in a further 10 seconds. Sketch the velocity time graph for the motion. Great. We are supposed to sketch the velocity time graph. So on the Cartesian plane, it is simply a graph whose y-axis is velocity in meters per second and s-axis is time in seconds. Being the first example, I want us to take our time and draw. Once you are able to master this, we can now speed up. The sentence says, a car initially at rest. Earlier, we learnt this, that when you say something was initially at rest, all it means is its initial velocity is 0. So for this statement, it means that the car started from rest, and that is with a velocity of 0 meter per second. That is the starting point. It continues to say, it then accelerates uniformly to a velocity of 20 seconds meter per second for 10 seconds. Look at the word here, accelerate uniformly, which could be turned to mean uniform acceleration. And I trust you have remembered how that graph looked like. So the graph called uniform acceleration or constant acceleration starting from 0 moves like this. Yes. This is where the car gets to. At this point, the sentence says it attains a velocity of 20 meters per second. That means that where it gets to corresponds to 20 meters per second on the velocity line, and within a time of 10 seconds. So that is it. We have been able to sketch the first sentence, that was a uniform acceleration starting from 0. Secondly, this is now the end point of the car, where it has gotten to now. So we continue from there. The sentence says it maintains this velocity. If a velocity is maintained, it simply means a constant velocity, a uniform velocity. And the graph which corresponds to uniform velocity or constant velocity is this. That is it. So it continues from where you got to or truncated initially. And this maintaining of the velocity was for 5 seconds. Friends, for the time being, from the very point of starting to where it is here, the car has spent 10 seconds in a journey. And so if the velocity was maintained for 5 seconds, you have to add that 5 seconds to the 10 seconds to tell how long the car has been in motion. And so when you translate it down, this is 15 seconds, meaning the 5 seconds is not lost. If you want to know the time between this point and that point, it's simply the 15 seconds minus 10 seconds, and you still have the 5. So I want to say that for the time, it needs to be added as we move forward on our sketch. Now, the car is in a constant velocity. The sentence then says, before it decelerates to rest. Deceleration here means retardation, being brought to rest, a decreasing acceleration. So from this point where the constant velocity reached, the next is the car comes down that way. And it took 10 seconds for the deceleration. Having understood what I said earlier, you have to add this 10 to the 15, and the time will be recorded as 25. So for this question, the total time taken for the whole journey was 25 seconds, but at various acceleration points. In the beginning, it accelerated uniformly. At a point, it had no acceleration, but it had a constant velocity. Then at this point, it decelerated. So please take notice of this. Don't confuse uniform acceleration with uniform velocity. Uniform velocity is a 0 acceleration. Thank you very much. So this is the sketch. Let's move to example number 2. A car starts from rest and accelerates uniformly to a velocity of 50 meters per second for 20 seconds. It then maintains this velocity for 10 seconds. The brakes are applied and the car comes to a full stop in 5 seconds. Sketch the velocity time graph for the motion. So we have the y-axis being velocity and the x-axis being time in second. Again, the car starts from rest, which translates to mean that it starts from 0. That is the starting point. And then accelerates uniformly. That is uniform acceleration. Uniform acceleration. So from 0, it projects as this way, as uniform acceleration. At this point, we are told it stops at 50 meters per second on the velocity line. That is 50 projected onto the velocity line. And it took a time of 20 seconds. So on the timeline, projected downwards as 20 seconds. So that is the first sentence, how it has been sketched. From this point, it then maintains this velocity. Maintaining velocity means constant velocity. Constant velocity. And it took 10 seconds for that. And so that will be added to the 20 to make 30 seconds. From this end, the brakes were applied and the car comes to a full stop in 5 seconds. Coming to a full stop means that from the 50 up here, it decelerated to rest of 0. And that will be from this end, the car comes to a full stop. It moves like this, down to 0 on the velocity. But for the time, it is 5 seconds. So you add the 5 seconds to the 30 to give 35. So this is a sketch for this problem. I trust you have understood it very, very well. Let's move on to example number 3. Example 3 says, a particle accelerates uniformly from a velocity of 5 meters per second to a velocity of 30 meters per second for 5 seconds. It maintains this velocity for 5 seconds and finally returns to a complete rest in 5 seconds. Sketch the velocity time graph for this motion. Okay, so this is our already answers that we know. Starting from, it says a car accelerates uniformly from a velocity of 5. So mind you, this did not start from rest. So there could be 0, all right, but it started from 5. So this is the 0, but it did not start from there. And it was a uniform acceleration starting from 5. So somewhere about. Though it's not drawn to scale, but it still have to have some sense of reason and direction. So from the 5, we have a uniform acceleration which goes like this. From the 5, uniform acceleration. And that truncated at a velocity of 30. So this point corresponds to 30 meters per second and also translates to be 5 seconds on the time. From this end, it maintains the velocity, making reference to this 30. So maintaining velocity simply means a constant velocity. It travels along this way like that for 5 seconds as well. Now, adding that 5 seconds to the already 5 seconds, we get 10 seconds. At this point, it continues to say retards to a complete rest. So from this end, the car retarded, it decelerated, it came to rest at 0. And that is a graph called deceleration. The deceleration continues from here like that. That also took 5 seconds, meaning the time will now be 15 seconds. I trust you have understood these first 3 examples as we have taken our time to explain. Thank you very much. Let's look at example number 4. A vehicle accelerates uniformly from a velocity of 2 meters per second to a velocity of 10 meters per second for 10 seconds. Before the brakes are applied to bring the vehicle to a complete stop in 10 seconds. Sketch the velocity time graph for the motion. I urge you to pause the video, sketch it, then you follow to see whether you're able to do it. But I trust you will be able to do it. So let's continue from here. With this, our answers labeled, it says that this vehicle accelerates uniformly. That is uniform acceleration, goes this way. but it does so from a velocity of 2 meters per second, meaning it did not start from 0. No, that is not it. It's not rest. Rather, it started from 2 somewhere here, and it was a uniform acceleration. So it goes that way. It then ends at a velocity of 10 meters per second. So that is the velocity, 10 meters per second. And the time that corresponds to it is 10 seconds. Great. From this end, the question continues to say, before the brakes are applied. It means right from this end, the brakes were applied and the car came to a stop. It retarded. It decelerated in 10 seconds. So there was nothing like maintaining of the velocity. So just two of the graphs, uniform acceleration, deceleration. So from here, it comes down straight. Also in 10 seconds, you add that time to that, and the time will be 20 seconds. I trust what you drew and what I have drawn were the same. Let's move to example number 5. A car travels with a constant velocity of 15 meters per second for 25 seconds before decelerating to rest in a further 15 seconds. Sketch the velocity time graph for the motion. Great. So this is already labeled as taking the sentence one after the other. You can say this car initially started with a constant velocity. So constant velocity of 15 meters per second. And we know how to draw that graph. So if this is the 0 for the beginning, 15 will be somewhere here. That 15, the body started there, but with a constant velocity. That is it. And it took the time of 25 seconds. So bringing it down, you project, and this is 25 seconds. Friends, I will want to say, get used to what it means by constant velocity graph, uniform acceleration, then deceleration. Just these three, and you'll be able to draw as I'm doing. From this, the car decelerated to rest in a further 15 seconds, meaning from where it got to at this end here, the next graph to add is a deceleration to rest. And that means we go like this, and the time allocated for it was 15 seconds. You add up to 25 and you have 40 seconds. So this is the graph for this narration. Thank you. Example number 6. So I'm trying to vary all the graphs. It says a car moves with a uniform velocity of 5 meters per second for 10 seconds and then accelerates uniformly to a velocity of 35 meters per second for 15 seconds. The car finally returns to rest in a further 15 seconds. Sketch the velocity time graph of the motion. Okay, so this is already prepared as taking them one after the other. Initially, this car was traveling on a uniform velocity, which means constant velocity or no acceleration of 5 meters per second. So the origin is already there, 0, but we're not starting from there. We're starting from somewhere here, 5. And the graph interpretation here is constant or uniform maintained acceleration. And that goes like this. It ends here, corresponding to a time of 10 seconds. It comes down, and that is 10 seconds. From this same point where it ended, don't go and start again, where it ended, the car then accelerates uniformly, meaning uniform acceleration, which goes like this. So from this point, this car accelerated uniformly like that to a velocity of 35 meters per second, meaning this corresponds to 35 meters per second. So initially, it was 5 meters per second, but it was on a constant velocity. At this end, the car then traveled uniform acceleration to 35 meters per second for a time of 15 seconds. So you get this one down 15. You then add the 15 to the 10 to make 25. So that even if you want to know the time here, it is 25 minus 10, so giving you the 15. From there, the next is the car finally retards to rest in a further 15 seconds. That is, from this end, it is a retardation. Right from this end, it projects downwards to 0 in 15 seconds, which is also added to the 25 to give 40 seconds. So this is the graph or the sketch for this kind of question. Let's look at last but one example. Example number 7. A body accelerates uniformly from rest to a velocity of 50 meters per second for 10 seconds and decelerates to a velocity of 35 meters per second for 5 seconds. It then travels on that constant velocity for 5 seconds before being brought to a full stop in 10 seconds. Sketch the velocity time graph for the motion. So I will want you to pause the video and try it. But this is how it will be. Okay, so first, the body accelerates uniformly from rest. So the starting point now is rest. Rest means 0. And the nature of the graph there is uniform acceleration. So that is how it is. Uniform acceleration. And it got to 50 meters per second in a time of 10 seconds. So that is the first graph. Again, there was a deceleration to a velocity of 35. It did not say deceleration to rest. Rather, it descended, it decelerated, it decreased. But from the 50, it did not get to 0. It got to 35. So deceleration is this. But it did not get to the 0 mark. This point here corresponds to 35 meters per second with a time of 5 seconds, which is added to the already 10 to make 15. From this end, it then maintained or traveled on a constant velocity. So from here, the car was on a constant velocity, and that constant velocity is drawn this way for 5 seconds as well. So on the timeline, you add 5 seconds to the 15 to make 20. From here, it says before being brought to a full stop. Full stop means that it's now decelerating to a full stop in 10 seconds. So from this end, it translates downwards to 0 lie. This 0 is for both time and the velocity. So it's now on 0, and that corresponds to 30 seconds since the time was 10 seconds added to the 20. So this is a graph. Compare it to yours. Lastly, it goes like a body initially at rest accelerates uniformly to a velocity of 15 meters per second for 15 seconds. It maintains this velocity for a period of 5 seconds and then uniformly accelerates to a velocity of 30 meters per second for 10 seconds. The body is then brought to a uniform rest in a further 10 seconds. Sketch the velocity time graph for the motion. Okay, so that is our graph. Starting, it says it started from rest and it did a uniform acceleration. So starting from rest means 0. That's the starting point. And it was a uniform acceleration. So that is it. It got to a velocity of 15 meters per second for a time of 15 seconds. So it comes down as 15 seconds. From where it ended, it maintains this velocity. Look at it. It maintains this velocity, which means constant velocity, for a period of 5 seconds. That means you add the 5 to the 15 to make 20 seconds for the uniform velocity. And then uniformly accelerates. So another uniform acceleration. Before that, which says accelerate uniformly, maintain velocity, you are now back to another uniform acceleration to a velocity of 30 meters per second. So from the 15 meters per second, it's uniformly accelerated up like this to another velocity called 30 meters per second in a time of 10 seconds. When the 10 is added to 20, that makes 30 seconds. It continued then to say that the body is then brought to a uniform rest from where it has gotten to now at the 30. The next graph is uniform rest, retardation, and that is how it is. It took 10 seconds. When added to the 30, that makes 40. So friends, this is the sketching of the velocity time graph for the various questions. Study it, know it very well. It will set the foundation for the next class, because we are now going to calculate the distance and some few parameters on it. But your strength will be in your ability to sketch this graph out of the question. Thank you very much for your audience. I welcome you to yet another lesson, which will be well tailored to enhance your understanding. So stay tuned and let's follow up with the next lesson. God bless you.